Okay, this is just a super fast add-on video to show you how to do very, very inexpensive and simple copper plating. Now the first video is right here, if you want to click on it, which shows nickel plating. And the nickel plating video gives you a lot of extra details to get a good plate, which are exactly the same when you're doing copper plating. So go ahead and click on that link if you'd like an in-depth step-by-step of the nickel plating process, and just switch out your copper sulfate for the nickel ammonium sulfate, which is shown in the nickel video, and you'll get exactly the same results. So the reason for making the second video is actually here. Now, buying the chemicals, a lot of people have told me they're very expensive. And I know when I went to the chemical store or when I ordered them online, it might be $20, $30 for the copper plating chemicals, or even more, and even more for the nickel chemicals. So I happened to be in the hardware store, and my roots were growing into my septic system. And they recommended a bottle of this. Now this is Root Kill. Dun, da, da, da. Drum roll, please. And when I looked at the ingredients on Root Kill, it was copper sulfate. Actually, technically, it's copper sulfate, and it's got, let's see, it's not a pure copper sulfate pentahydrate. But it sounded like the same thing I'd been using for copper plating. And when I looked at the crystals, I thought, well, it's going to be adulterated somehow. But instead, I found these perfect blue crystals, which looked exactly like what I'd been using for copper plating. So I assumed that this was possibly a good solution for copper plating, which was much less expensive. A few ounces of copper sulfate from the chemistry store can run you $20 or $30 plus shipping. This is $9. It's available at any hardware store. So this is going to be our big experiment today. So let me kick on the water heater back there. I've got distilled water in here. A number of people wrote in on the original video and said, instead of using the tap water I've been using, use distilled water. I haven't noticed any difference, but distilled water is very inexpensive, and it certainly has to have less contaminants in it than tap water would. So we've got our scale here, and I'm going to measure 1.5 ounces of our copper sulfate crystals. Copper sulfate pentahydrate. Let's be specific. There we go. Super simple to do. And our water is heating up to boiling behind there. So I've got a measuring cup. It's going to be 1.5 ounces of the crystals to 2 cups of boiling water. And I had actually preheated this water, so it's nearly boiling right now. So we'll grab our 2 cups. I actually don't think that these measurements are quite as important as they might be presented, but what the heck? When you're making a recipe, why not stick right to it? But I've used a little bit more or a little bit less, and it really didn't make a big difference. We've got our mason jar. We're just going to pour in that boiling water. Now, another thing I've done when I haven't been in a hurry is to just put regular water in here, and regular distilled water, and then set the jar out in the sun, and it got warm enough for sure to do some halfway decent plating. Now once you've got the crystals and you've got your hot water, you can just agitate it until the crystals dissolve. This won't take long at all, and let's see, this is truly an experiment. I'm not positive it's going to work. Maybe we'll get some strange plate going on, but I have a strong suspicion we're all going to save a bunch of money on copper plating by using the Root Kill crystals, and I believe they're available at any Lowe's or any Home Depot. Okay, those crystals are just completely dissolved in there. The water is still hot. I've been told about 140 degrees is actually optimum for plating. Cold water will still plate. It just doesn't work as fast or quite as well. So you might as well warm it up. And as I mentioned, I've set this in the sun before to do that as well. I've got 3 volts, just 2 Penlight batteries, which are connected in series. Our positive lead, which is our anode, is connected to a copper pipe, which is just dangling in the solution. And it's pretty warm too. And then our cathode is our negative lead coming from the batteries, which is usually I connected to an alligator clip. In this case, I got fancy and I made a little charge rail, they call this. And this coin, this was something that was very difficult to show in the last video. I nickel plated this penny. So you'll notice this penny is not copper colored, it's silver colored, just like a quarter would be. So that nickel plate, because this actually happened to be a zinc plated 1943 penny, so I did a nickel strike on it, as they call it. But I'm hoping that'll show us whether the copper plating is working or not. So I'm going to put our penny in the little charge rail, which is just held on by friction. It's difficult when I'm reaching around the camera. And once again, as I said, it was difficult to show copper or silver coloring, but hopefully you can see the difference between the copper wire and the coin. So this has been agitated before I ran the camera, and let's go ahead. I'm just going to put this coin in about halfway, if I can see through the jar here, and we'll give it a few minutes to see if we're going to get a copper plate. So actually, I'm pretty excited. Does copper sulfate pentahydrate, $9 for a couple of pounds, will it do a copper plate just like regular copper sulfate will? And I'll have to look up the MSDS as well on this substance and make sure there aren't any additional dangers before I post the video. But I'm excited, and I'm really hoping when I pull this out we'll see that a copper plate is beginning to take place. And look at that. Actually, the side that's facing the copper pipe there has naturally picked up the copper first, but you can see a copper plate is already starting to form on the penny there. So that was just a couple of minutes, not even a couple of minutes. We'll put it back in and we'll let that continue for a bit, and then we'll pull it out and have a really good look at it. So this will probably take several minutes, so I'll go ahead and shut the camera off. Wow! Oh, look at that. Now I don't know, again, it's difficult on camera to get, especially with the lighting, to get a view, but look at that. We've got a very solid copper plate starting on there right away, and even though I had the face of the coin pointing towards our anode there, it actually plated both sides very effectively. So that's a 50-50. As a matter of fact, let me pull it out of there, and it was just in a few moments, a very, very quick, look at that plate. Wow, so it appears that this solution is going to work quite well for copper plating. It's still experimental, so let me know how it works out for you if you decide to try it. And as I said, I'm going to look up the MSDS on this and make sure this is a good idea. And let's give this a quick scrub in the sink, because I just want to make sure we're getting a good plate and that it has good adhesion, that it's not going to flake off of our coin that we just plated. All right, the moment of truth. We've got our coin here, and it's partially plated in copper, partially plated in nickel. A lot of people have written me to ask how strong is the adhesion of these plates with these low voltages. And I don't know overall what your results will be, but so far with mine, I've been telling everybody it's at least stronger than paint. If this were spray painted, hopefully with our new copper here, we're going to get the same adhesion. Let me turn the water on. If it were paint, spray paint or the like, this is an abrasive Scotch-Brite pad, and I put cleanser on it. So it's even got an abrasive on top of an abrasive. And it's really good for shining the coins up. Sometimes I use Barkeep's Friend, but in this case, I'm using a regular Clorox type bleach. And I'm just going to scrub the heck out of it. Now, this pad is really, I mean, this would rip up a pot or a pan. It would leave scratch marks on it. As a matter of fact, when I'm cleaning my coins, I don't use Scotch-Brite because it's actually too abrasive. But to show the adhesion of the copper on the coin, and I don't know, again, because of the shiny surfaces, if the camera can see that, but as I said, it seems to be stronger than paint, is all I've been saying so far. So it is a good, strong copper plate with this very simple method, and I'm really pleased that Root Kill may be an alternative to the more expensive chemicals. Yeah. Who are you? Are you in the shot? Are you in this shot? It's an accident, right? You didn't mean to be in the shot. You just happened to wander right by.